Single-phase AC circuits. Phase 4, Part 3. RLC parallel circuits. R is for resistance, L for inductive and C for capacitance. All single-phase AC circuits contain these three components, and they are known collectively as Z, or the total impedance in a circuit. Importance of topic. Remember, this topic is important for you to learn, and this is why you should care. Not only because it is great to know the reasoning and theory behind what you do, but also because it is a large part of your T1 exam paper. Anything from 5 to 8 questions out of a total of 20 will be on RLC circuits, phasors, and power factors. Phasors and power factor to be covered in the next 2 videos. Know this subject well, practice it, and you will have over a quarter of the exam finished and with full marks easily. In the first video of single-phase AC circuits, we looked at RL circuits. In the second video, RC circuits. This was important to learn them separately to learn this subject properly. It is rare that we will get RL or RC only circuits in an exam grade question. Maybe one at most. In this video, we will combine knowledge from video 1 and video 2 into this full version of RLC parallel and exam grade questions. Note: we can also have RLC series and parallel at the same time, however, it is mostly in Phase 6, so we'll cover that in a later video for your Phase 6 revision. In this video, we will focus on RLC parallel circuits only, so as not to overload you with information. We will do RLC series in the next one. Now on to RLC parallel example questions and solutions you will need for your exams. Here's what the RLC parallel circuit looks like. Draw it at exam, and put in the values given. This will give you a huge advantage over trying to picture it in your head. Also, if you make a mistake, the examiner can see that you understand the topic and can see where you went wrong and still award some marks. And remember, these are the same as video 1 and video 2 explainers. They just take longer to solve, but all the same formulas apply. Time for questions. Let's start with RLC parallel. Don't forget to pause or rewind as you need and practice along once you are competent to try. Question 1. Calculate the supply current. R equals 40 ohms, L equals 0.1 Henry, C equals 55 microfarads, and the AC supply voltage of 110 volts at 50 Hz. As always, draw out the circuit. As the inductor and capacitor values are not in ohmic values, we need to convert them. However, first we can easily find the current across the resistor, IR, as that is in ohms. Just use Ohm's law and put in the numbers. IR equals U over R. IR equals 110 over 40. IR dash equals 2.75 amps. Now convert the other two with XL and XC formulas. First, XL, because it is easier to do. XL equals 2 pi FL. XL equals 2 pi by 50 by 0.1. XL equals 31.41 ohms. Now XC. XC equals 1 over 2 pi by 50 multiplied by 55 by 10 to the power of minus 6. XC equals 57.87 ohms. Now with ohmic values for XL and XC, we can find the currents across the inductor and capacitor separately. Use Ohm's law again and this triangle as a visual aid for each. IL equals U over XL. IL equals 110 divided by 31.41. IL equals 3.5 amps. IC equals U over XC. IC equals 110 divided by 57.87. IC equals 1.9 amps. Now we can find IT, or I total across the supply as the question asks. This is same formula as we used in the previous 2 videos, with just a little bit added. It looks like this, and we just put in the numbers we worked out to get I total. IT equals the square root of IR squared, plus IL minus IC squared. IT equals the square root of 2.75 squared, plus 3.5 minus 1.9 squared. IT equals 3.181 amps. That would be full marks in this question. Let's do another example. Question 2. Calculate current taken from supply. This is a fancy way of asking what is total current, or IT. R equals 50 ohms, L equals 0.025 henries, C equals 110 microfarads, with a supply voltage of 120 volts at 60 Hz. Draw out the circuit. Again, we can find the current across R, as it is in ohms for our Ohm's law solution. IR equals U over R. IR equals 120 over 50. IR equals 2.4 amps. Now convert the other two with XL and XC formulas again. First, XL. XL equals 2 pi FL. XL equals 2 pi by 60 by 0.025. XL equals 9.42 ohms. Now XC. XC equals 1 over 2 pi by 60 multiplied by 110 by 10 to the power of minus 6. XC equals 24.11 ohms. Now, with ohmic values for XL and XC, we can find the currents across the inductor and capacitor separately. Use Ohm's law again and this triangle as a visual aid for each. IL equals U over XL. IL equals 120 divided by 9.42. IL equals 12.73 amps. IC equals U over XC. IC equals 120 divided by 24.11. IC equals 4.97 amps. Now we can find IT, or I total across the supply as the question asks. We just put in the numbers we worked out to get I total. IT equals the square root of IR squared, plus IL minus IC squared. IT equals the square root of 2.4 squared plus 12.73 minus 4.97 squared. IT equals 8.12 amps. That would be full marks in this question. Now, we know how to solve the questions. We can make it even simpler by breaking it down to a few steps to do in your exam. Using the same question and answers as question 2 previously, do these steps. Step 1. Draw out the circuit using figures provided in the question like this. Step 2. Using the formula booklet, or memory, write out all the formulas you think you will need. Marks can be given for correct formula used. Step 3. Find XL and XC. As C and L are not in ohms, convert to XC and XL. Enter answers onto circuit diagram and circle answers. Step 4. Find IR, IEL and IC. Step 5. Find IT. And job done. If the question is nice and gives us XC and XL, we have one less step to complete. One critical piece of knowledge for you is that sometimes they can be sneaky and ask you what is the supply voltage of an RLC parallel question instead of current. Do not panic. They will give you the current you need, and this is all you have to do. As the voltage does not change throughout the parallel circuit, it is all the supply voltage essentially. We just need the figures for one branch of the circuit. For example, we have a circuit the same as question 2. Draw out the circuit and just use Ohm's law. That is U equals IR multiplied by R, or U equals IL by XL, or U equals IC by XC. Each branch, when calculated out as shown, gives us 120 volts rounded up. The same as is given in question 2. Note, this also applies if they asked you to find a value of a component in a branch of the parallel circuit. For example, what is the value of the resistor in this circuit, using question 2 as an example again. Using Ohm's law triangle, we can see that R equals U over I. In parallel circuits, as I changes in the branches, this becomes R equals U over IR. R equals 120 divided by 2.4. R equals 50 ohms. This matches perfectly the resistor value given in the question. Here is an example RLC parallel question that is likely to be asked in the exam for you to solve. You should pause the video now and try to work out the answers. I will give the answers on the next slide. Question for you. A resistor, R equals 100 ohms, capacitor, C equals 100 microfarads, and inductor, L equals 0.025 henries, are connected in parallel, and this combination is supplied from a 230-volt AC power source. Determine the current drawn from the supply. Just follow the steps as shown previous and rewind if you need to. Have your formulas for RLC parallel and calculator ready beside you. Good luck. Answers of example question. XL equals 7.85 ohms. XC equals 31.83 ohms. IR equals 2.3 amps. IL equals 29.29 amps. IC equals 7.22 amps. IT equals 22.18 amps. If you got the answer, then well done. If not, then don't worry and try again. That concludes RLC parallel. Take your time learning this one as it is super important for your exams. Remember, for extra marks in the exam, write out all your work. Use correct SI units such as A for amps. Show formulas used. In the next video, we will RLC series questions in the same detail as this video. And that will almost completely cover you for the majority of RLC questions, not including phasors and power factor, which will be covered after the RLC series video. Feel free to look back over this or previous videos if you feel stuck and it will make sense, and ask questions in the comments section. Cheers, and see you on the next one.